Hi everyone, in this video I'll be solving the Day 1 programming challenge in Advent of Code 2025. So if you want to follow along, you can of course yourself go to adventofcode.com/2025 and you'll see all the problems there. As always, there's a little story attached to the problem and it's kind of fun to read it, but we're not going to worry too much about that. I'll just explain the problem directly to you. So basically there's a dial. Where is it here? There's a dial with an arrow on it, and around the dial are the numbers 0 through 99 in order. And you can turn the dial, or I guess I think of it as turning the arrow on the dial, but that's equivalent. And so we're given an input file with a sequence of rotations, one per line, so it's either left or right by a certain amount. And actually, let me show you that real quick. So on the right is the input file. So the first line here would be right 26, and then the second one would be left 12, and then left 47, and so on, right? And we've got thousands of lines here of rotations you're supposed to do on the dial. And so the problem is to figure out how many times the dial is pointing at 0. So we start at 50, and then we do the rotations, and then at some point, we may hit 0 along the way as we rotate, and we want to count the number of times it hits 0, basically. Well, let me just draw out the problem just to be extra clear about what's going on. So we have this dial, or the circle, with numbers going from 0 to 99, right? So 1, 2, 3, 0, 1, 2, 3, all the way around up to 99 over here, right next to 0, right? And so 50 would be at the bottom. And we've got this arrow that's initially pointing at 50, and we have to do this sequence of rotations. So this would be 25, this would be 75, and we have to do either left or right rotation. So this would be a left rotation, this would be a right rotation, and so right here just means clockwise, left means counterclockwise. And yeah, so let's say if we go back to our input sequence here, so the first one is R26, so that means we have to turn it right 26, so that means the arrow will be pointing here after the first step, right? And then after the second step, which is L12, it'll be maybe around here, and then at some point it may be pointing at 0, and that's when we kind of increment our counter, and that's what we want to count, like how many times does it end up there. So let's start writing some code to solve the problem. So I've got these 3 lines here already, which just import the data and process it a little bit. So I'm converting each line to an integer. So right is turned into positive, and left is turned into negative. So we have 26 and then minus 12. So right 26, left 12, right, and so on. And that just makes it easier to work with the data here. So it's just a list of integers. And we're going to loop over that list and do the rotations. So for n in lines, we're going to, well, first create a position variable, which starts at 50. And we're going to keep track of our zeros, the times we hit the 0 position, basically. And so this is where modular arithmetic is going to be super useful. So we're going to let's see, we're going to change our position by n, right? So we're going to add n to the position, and then we're going to take mod 100, right? Because if we're at 99 and we add 1, then we're back at 0, basically, or we want to be back at 0. So position equals position mod 100. And then if pos equals 0, then we're going to add 1 to our zeros part 1 variable here. And then let's just print it out, zeros part 1. And that is the correct answer for my input here. Now there's a part 2 to the problem. So let me go back here. So in part 2, we're supposed to count zeros also when they happen during a rotation. So during or at the end of a rotation. So that makes the problem a little more complicated. we could do a brute force approach where you kind of rotate through every tick on the dial, and that should count zeros correctly, even the ones that happen during a rotation, but then every rotation is kind of broken up into many rotations, and you have to have this inner loop, which is inefficient. So let's try to do it in a smarter, more efficient way. Let's consider only right rotations for now and worry about left rotations afterwards. So let's consider an example. If we're at 90 here and we have to rotate 20 to the right. So 90 plus 20 is 110, right? But we're doing mod 100, so that ends up just being 10, right? So, and we did pass 0, right, in that rotation, right? That 0 was reached during the rotation. So we would want to count that. So one way to count it is through the through the quotient of the division, basically. So 90 plus 20 equals 110, right? And 110 mod 100 is 10, right? So that's the remainder after division. But we can also consider the quotient, right? Which is basically how many times does 100 fit into the sum here? And that's 1, right? And that corresponds to the number of times we passed by 0 here during the rotation. So that approach works for right rotations, but what about left rotations? Well, we could do something similar for left rotations, but that would involve dealing with a bunch of edge cases, which are annoying. So instead, we're going to turn left rotations into right rotations. Let me show you what I mean. So here, if we, again, assume that we're at 90 right now, and we want to do instead of right 20, we'll do left 20, right? And so we want to end up around here, let's say. That would be a left 20 rotation. Instead of doing that, we're going to first reflect about the vertical axis here. And so if we reflect 90, we'll end up at 10, and then we'll do a right rotation of 20, which will put us around 30 here. And then we reflect again about this vertical axis to get to our final position here that we want to end up at. So that avoids a left rotation, and it just turns one left rotation into a reflection, a right rotation, and then another reflection. And so that should do the trick for left rotations. Let's look at some code next. The reflection is not too hard to code, right? We can just do if n is negative, then the position equals 100 minus the position mod 100, right? In case position is 0, we do need to take a mod 100. And then we only do right rotations, right? So let's do absolute value of n here. And then instead of this, we'll do, we need the quotient and the remainder, right? So we can use the div mod function in Python or do floor division, right? But I'll use qr equals div mod, pause, and then 100, right? So q will be the quotient, r will be the remainder. And we do want to set position to be the remainder. And then q is what we want to count for our second part here, right? So 0 is part 2 equals 0. And then, so 0 is part 2 plus equal to q. And then we don't need this anymore. And then we can print the second part. And, well, I made a mistake here somewhere. So what is going on? Oh yeah, we got to reflect back, right? Otherwise, we don't get the right position. And those are the correct answers for my input. Well, thanks for listening. I hope that was at least somewhat helpful, and see you in the next video.